This video is related to this problem set about function composition, and I just wanted to give a few tips and clues about how to get started on some of these problems if you happen to miss class. What we have here is the function f of x represented, represented by a table. And we also have the function g of x represented by a table. We don't know the rule or the equation that takes x and converts it into these output values. And it's not really important to us for the purposes of this exercise. What we're asked to do over here is to make a new table that represents the composite function. And the composite function in this case is g of f of x. And so let's think about what g of f of x will be in the case of x equal to 0. It looks like this, g of f of 0. So the idea is that if I know what f of 0 is, whatever the function f gives me when I put 0 in, I can take the output of that function and use it as the input to the function g, and that will be the result of the composite function. So let's go look and find what f of 0 is. Here's our function f, and when I put 0 in, I get 5 out. So this becomes g of 5. And now it's as simple as using our function table for g in order to look up the value of that function when x is 5. Well, when x is 5, g is 10. So this equals 10. So g of f of 0 is equal to 10. And, it's not necessary to write this out every time. This is meant to just kind of illustrate what it is that we're doing. Let's think about when x is equal to 1. I want g of f of 1. So f of 1 is 7. And then I take that as the input to my function g. G of 7 is equal to 8. So 8 right here. And that's probably enough to get you through the entire first page of this problem set. On the second page, we're doing a very similar thing, but instead of looking up values for the functions f and g in tables, we have these graphs that represent these functions. And so we're going to have to use the graph to look up the inputs and outputs of these functions. And what I like about this problem too is it's an application problem. The first graph, f of x, tells us the relationship between how fast a car is traveling and what its fuel economy is in miles per gallon. So in other words, what we see from this graph is that when you're going slow, your fuel economy is not great, but it continues to improve as your speed increases. And then when you reach maybe about 40 miles per hour, that's when your fuel economy is maxed out and you're getting the best fuel economy. And if you try to go faster, then your fuel economy decreases. So this one over here, this graph is the graph of g of x, and we see that the fuel economy if we know what our fuel economy is in miles per gallon, we can use that to determine what we're actually paying per mile of driving. And maybe this makes some intuitive sense. The more miles per gallon you get, the less you're paying per mile. So the combination, or I should say the composition of these two functions, there's really only one way to compose them, because you'll notice that the independent variable here, or in other words, the input of the function, is the fuel economy. And that's the output of this function. So if I want to relate the speed that I'm going with how much my fuel is costing per mile, how much I'm basically paying to drive per mile, then first what I do is I find the speed that I'm going, and I can look up the fuel economy for that speed, and then I can take that fuel economy and use it to look up the actual fuel cost. And so there are some questions here that have you reading these graphs, and I just want to make sure you see that you are asked to explain the meaning of your answer in terms of the car. So you will have to actually write a sentence. It's not just about evaluating this function at a particular value, you got to explain the meaning of it. What does it mean? What does 65 mean in the context of this function, right? It's a speed. And so we will just go down to this table right here and notice that we're going to, again, create a table of the composite function, but we're doing this using the graphs that we have. So let's imagine that x was equal to 10, and we want g of f of 10. Let's go look at the function f to figure out what f of 10 is. That's right here. So if I'm going 10 miles per hour, then my fuel economy is 15 miles to the gallon. So really what I want is g of 15. So because f of 10 is equal to 15. So let's look at the graph of g of x. If we're getting 15 miles to the gallon, that comes out to 8 cents per mile. So g of 15 is 8. And I'll put that right there. So you can do that to figure out what the composite function gives us for these different values of x.